Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's weekly contest, count paths that can form a palindrome in a tree. This is one of those problems in which if you start from the first principle, you will be able to solve the problem very easily. If you directly jump to finding out the actual optimal solution, you might face difficulty solving this problem. So as always, we'll start from the very basic and we'll see how to optimize it along the way. So let's start. The problem states that you are given a tree and the tree is rooted at node 0. Now you are also given a parent array which denotes the parent of every node, and obviously parent of 0 is -1 because tree is rooted at 0. Now along with this you are given a string s of the same length where si denotes the character assigned to the edge between I and parent I. So every edge has a character assigned and that character is denoted by s of I. Now because 0 doesn't have any parent, so s of 0 can be ignored, right? Now you need to figure out the number of pairs u comma v such that if you take the characters assigned on the edges on the path from u to v, you can rearrange them to form a palindrome. So if you can do that, then u comma v is a valid pair. You need to count all such valid pairs. So let's look at an example. Let's say this is the parent array and this is the s. So as mentioned, this denotes the parent of 0. -1 says that there is no parent of 0. This denotes the parent of 1. So 1 has a parent of 0. So you can see 1 has a parent of 0, right? Then 2 also has a parent of 0. 2 also has a parent of 0. 3 has parent of 1. 4 has parent 1. 5 has parent 2, right? So this is the tree that you are forming, and you are also given this s which denotes the characters on the edges. So notice that s of 0 can be ignored because 0 doesn't have any parent. Now this c denotes that c is the character on the edge between the parent of 1 and 1. So parent of 1 is 0. So between 0 and 1 the character is c. In the same fashion, this a denotes that a is the character on the edge between parent of 3 and 3. So parent of 3 is 1. So a is the character between 3 and 1, right? So this is how we'll form the tree. Now we need to count the number of pairs which, if you traverse the characters on the path, you will form a palindrome, or you can form a palindrome by rearranging the characters. So there are 8 valid pairs which are given here. Let's just look at one of them. So let's see 1 comma 5. So if you see 1 comma 5, this is a valid pair because if you see the characters in this path CAC, you can rearrange these characters to form a palindrome. So CAC itself is a palindrome. So because you can rearrange the characters to form a palindrome, you can say this 1 comma 5 is a valid pair. So let's just take one more example, 3 comma 5. So in 3 comma 5 you can see the characters are AC. This AC is not palindrome, but you can rearrange this to something like ACCA or CAAC. Both are palindrome, and because you can rearrange to form a palindrome, this 3 comma 5 is also a valid pair. So in the same fashion, we will have this 8 valid pairs, and hence the answer here is 8. So hope the problem statement is clear. Now how to solve this? So as always, I would strongly encourage you to pause and try to come up with the brute force solution by yourself. So don't worry about the time complexity, just try to solve the problem in solve the given problem with any time complexity with the brute force solution. So hope you thought about it. What is the brute force solution? Notice that we need to count the pairs, right? So one possible brute force solution could be, okay, I will try every possible pair u comma v, and for every pair I will see if it is valid or not. If it is valid, I will increment the result. Otherwise I will not increment the result, right? Now your job is now to figure out, or your job is now how to figure out whether a path u to v can be rearranged to form a palindrome. So basically you need to figure out whether u comma v is valid or not. So u comma v is valid only if the path between u and v, the characters in the path between u and v can be rearranged to form a palindrome, right? So these are the characters between u and v, right? So you have to somehow figure out whether they can form a palindrome or not. So let's just first collect the characters. So you can see that there is a. So you will, let's say you are maintaining a frequency array. So a, you increment the counter of a. C, so you increment the counter of C. Then you see another A, so you increment the counter of A. You see another C, so you increment the counter of C as well, right? Now this is the characters in the path U to V. Now you need to somehow tell whether this character set can form a palindrome or not. Now what is the definition of palindrome? Palindrome basically says that if it should be read same if you did it opposite, right? So in other words, if it is even length, then every character, like this character should match this one, this character should match this one, and this character should match this one, right? So every character has a matching character. So in other words, you can say every character should occurs twice. So if you have, let's say, two character here, so you can simply say I will assign this A to the first one and one A to the last one, right? And then you have two C, so you will say okay, I will assign this C to the second one and C to the second last one, and so on and so forth. So if you have all the even numbers in this array, then you can form a palindrome for sure, right? But let's say you have an odd number. For example, let's say instead of like for some path you get this. Now B is just single. Now if there is just one odd number, you can still form the palindrome by putting it in the middle, because if you put it in the middle, then also this is a palindrome. But if there are more than one odd number, for example, let's say there are 3 C's instead of 2 C. So in that case, you can see there are two odd numbers. So you can't form a palindrome with this at all, right? So the logic is simple. You will go over every possible pair, collect all the characters in the path of that pair, see how many odd numbers are there in this frequency array. If the number of odd numbers is less than equals to 1, then this pair is valid, or in other words, you can form a palindrome. If the frequency of the odd numbers is greater than 1, you can't rearrange this anyhow to make a palindrome. So hence this pair that you are considering is not a valid pair, right? Now what is the time complexity of this entire approach? You are considering every pair, so there are total n square pairs, right? Now for each pair, what you are doing, you are trying to collect the characters and build this frequency array. So collecting this character will take order and time, right? You can one way to collect the character is to find the LCA. Once you find the LCA in order n, you can now go from U to LCA and V to LCA, and that will take again order and time. And finally you can iterate over this array and see how many odd elements are there. So that will take like 26 iterations, because this can be 26. So let's just ignore that and replace it with some C. So this is the total time complexity of this particular approach. So in other words, like this complexity is order n cube. Now this will surely not pass because n is very huge. Even n square will not pass. But let's see how to optimize this further. Now, which of these factors you can easily remove, or you can think that can be removed easily? So we are iterating over every pairs, and we need to count the pairs. So this n square is coming from pairs directly. So if we don't iterate over pairs, it means we need to figure out some way to tell how many v's are valid for a particular u. This part is very not that straightforward, but for each pair we are trying to build this frequency array, and building this frequency array takes this part, n plus n. Now after frequency array is built, this part is sorted. Like you can iterate over the frequency array in constant time, or around constant time. So if we want to optimize, we need to somehow think to reduce this particular factor. In other words, we need to build this frequency array efficiently. Now how to do that? Again, I would strongly encourage you to pause and try to think about this yourself for some time at least. Now one simple way could be to just keep this frequency array with every node, and you will just update it while doing a simple DFS or BFS, whatever you want. So let's say you maintain a frequency array with each node. Now root has this frequency array of 0, 0, 0. So I'm just showing you three nodes, three elements here for A, B, C, but in the actual problem you will have all the lowercase English letters, so this will be 26, like this array size would be 26. But for now let's assume that there are 3 characters only, A, B, C, so we will keep it short to 3 numbers itself. So for 0 it is 0 0 0 because 0 doesn't have any edge at all, right? Now once you go to 1, because you have gone to 1, you can say okay, I've come to 1, now I have seen 1 C, so I will just simply increment the counter of C, right? In the similar fashion, when you come down to this 2 via A, you will say okay, I see one more A, so I will just increment one more A here, and the final array would become 1 0 1, right? Now in the same fashion you will simply do DFS and build this entire array. Now how to calculate the actual frequency? So we have two n's here, right? So first n was coming from the fact that we want to find the LCA, and second n is coming from the fact that once we find the LCA, we need to now iterate over the path, so u to LCA and v to LCA, right? So now u to LCA and v to LCA is straightforward. Let's say this is u, right, and this is v. So let's just take this is just an example, we'll look at another example, but this is u, this is v, and let's say this is LCA, right? So this is the lowest common ancestor. Now from u to LCA you already know the counts, and from v to LCA you already know the counts, right? So second part which was giving us order n was erased. Now if we can somehow figure out LCA efficiently, then entire thing can be solved in just order C time. So figuring out LCA is a standard problem. We have discussed the optimal solution of how to figure out LCA in a usual tree in logN in this channel in the past. I will link the video in the description or somewhere in the top right section. I would encourage you to check this out. So in a sense we can compute LCA in logN as well. So computing LCA takes a logN time, right? Now after we computed the LCA, we know that we can find out this array u to LCA and v to LCA in just order C time, right? Like we can just sum these two array, which will take order C time, assuming that the size of the array is constant. So this is now what you are doing for every pair, and you have total n square pair. So in total you will have the complexity would be n square log n, right? Now you might be thinking that okay, what if v is not here, instead v is somewhere here? So in that case the LCA would be this, right? So how will you figure out the number of characters between u and LCA? So answer is straightforward. You already know the characters between root and LCA, so this you already know, right? So this is the number of characters between root and LCA. Now you already know the number of characters between root and u, right? This is the number of characters between root and u. Now if you want to find out the number of characters between u and LCA, you can just subtract these two and you will get that, right? So you will just subtract this array from this array and you will get what is the number of characters or the frequency array between u and LCA, and you can do the same thing for v and LCA. So you will take extra order C time to just subtract these arrays, and you can easily get the actual frequency between u and LCA and v and LCA. Once you get the frequency, you have this array. Now the approach is simple. We will just iterate over the array, figure out how many odd numbers are there. If the number of odd numbers is greater than 1, we will return, like we will not count that particular number, otherwise we will count that number, right? So in a sense this would be the pseudocode. We'll come to one particular thing here. So we are iterating over all the pairs u comma v. For each pair, what we are doing, we are trying to figure out how many odd numbers are there. So we have said that we'll first figure out LCA, right? And we'll then figure out what is the frequency in between u and LCA, and then what is the frequency in between v and LCA, right? But here what we are doing is we are simply summing the array up instead of actually computing LCA. And this is also correct. Why? Because if you think about it, you don't care about the actual values. You don't care that okay, A frequency was 2, C frequency was 3, or B frequency was 1. You don't care about that. The thing you care about is how many odd numbers are there, right? Now if you think about this, if you consider everything between u and root, and if you consider everything between v and root, this path is calculated twice, or is considered twice. So whatever characters will be there in this path will automatically get doubled. So in other words, whatever characters will be there in this path will not be contributing to the odd numbers anyways, right? Just to reiterate this part, we have this path from u to root, and we have this path from v to root. Now if you see, this path is computed twice, and because this part is considered twice, every character here is considered twice. So we don't like every character is considered twice, and hence every character which is present in this particular path is already nullified. Basically that will not contribute anything to the odd sum, and because that is fine and we only care about odd sum, we can skip figuring out what LCA is, and instead of figuring out LCA, we can simply sum these two array up and just see how many odd numbers are there, and that can give us the exact same result, right? So with that, we have reduced the logN as well from the complexity, and the complexity now is order n square, right? So this is how the pseudocode would look like order n square into C as well, and assuming that C is 26 and we are ignoring 26 for now. So we'll just sum these two arrays. Path u and path v are these arrays itself, and we'll just sum them all up. We'll see how many are odd, and if number of odd is greater than, if it is less than equals to 1, then you will increment the result, otherwise you will not increment the result, right? So this algorithm would work, and it would work in order n square time, but unfortunately even order n square will not pass because n is up to 10 to the power 5. We need to optimize this as well. Now how to optimize this? Again, optimize like if we need to optimize it, we need to reduce one of these loop. So we need to somehow skip iterating over all the v's, and we need to somehow know for a single u how many v's are valid, right? So if you are calculating any path which starts from u, you need to now figure out how many v's are there which are valid for this particular u without actually iterating over all the v's, right? So notice that what we are doing, we inside this loop we care about how many elements are there which have odd sum after summing up with path of u, right? So can you utilize this to come up with an algorithm in which you will not iterate over all the v's and still get the same number? So I would encourage you to pause and try to think at least for a few minutes. So the answer here is very straightforward. Let's start with even length palindromes only, because that is something which is easy to deal with. We'll come to odd length palindromes afterwards. So even length palindromes, how we have to compute how many even length palindromes are there in this particular tree. Now even length palindrome means that there will not be any odd sum. So every sum that we are getting here will be even. So every element is even. So basically there are two cases here, right? Odd sum equals to 0 and odd sum equals to 1. So odd sum equals to 0 means even length palindrome, odd sum equals to 1 means odd length palindromes, and we are considering even length palindromes right now. So in other words, odd sum would be 0, and we need to somehow figure out how many v's are there for a single u, such that if you sum them all up, every number is even, right? So think about it, we need every number to be even. And as we have mentioned previously as well, we just need to we just care about odd and even. We don't care about actual frequencies. So because we just care about odd and evens, we can simply reduce this array to either 0 and 1s instead of frequency. Why? Because we just care about whether the current element is odd or even, and that can be taken care by just simple 0 and 1 instead of maintaining the actual frequency. So basically we'll just do modulus 2 with every array. So this 102 will become 100, and similarly this 012 would become 010, right? Now we need to find out odd length palindromes, sorry, even length palindromes. Let's say this is u, right? Now we need to find out all the v's that will, if you sum something with 001, it will come as even. So basically everything would be 0 here. So that is something you need to find out. So what will come here? Think about it. If you want everything to be even, you have to make this 1 and everything else should be 0, right? Why? Because if this is 1, in other words, if you choose some v for which the frequency of a is odd, then you are saying that in u the frequency of a is even, in v the frequency of a is odd. Odd plus even will be odd, and because there is one odd element, you will not get a even length palindrome, right? So because you want only even length palindromes, we can't afford adding a odd number here. So we need to pick all the v's for which the frequency of a is even, right? Or frequency of a is 0. Similarly, we need to pick such v's for which b is as well 0, because again in the same, with the same argument, you can't afford having a odd number here, right? So, and with the same argument, you want the v's for which the frequency of c is odd. Why? Because the frequency of c is odd in u, right? This is u, so frequency of c is odd in u, and you want frequency to be even at the end, because you are calculating even length, you are computing even length palindromes, so you don't want any odd sum at all. So you want this sum to be even at the end. Because this is odd, you need to sum up with some odd number to get even, right? So this will also be, this should better be 1 in v as well. So in other words, what we are saying here is, if this is 001, then v should also be 001, right? Otherwise it is not possible at all to get even length palindromes. Now with this observation, we can simply maintain a map of all the frequencies, or all the frequency array, with this reduced constraint as well. Like we will not maintain the actual frequency, instead we will maintain 0 and 1, so that this part is straightforward, right? Now once you maintain this frequency array, you will say, okay, how many 001s are there? If you see here, if there are, like, let's say 3 001s, right? So if there are 3 001s, you will say any pair within this 3 will form a valid even length palindromes. So if you start with this u, any v with 001 will form a valid length palindrome, valid even length palindrome. So if the frequency of u is 3, it means you have 3 elements which have 001. So you can pair this up with this, you can pair this up with this, and you can pair this up with this as well. So in other words, if the frequency is c, you will be contributing c into c minus 1 by 2 number of even length palindromes, right? So hope this entire point makes sense. If you have any doubts in this particular piece, I would strongly encourage you to rewind and watch this piece again to understand this, because odd length palindromes are a bit complex than this, and understanding of how we are calculating even length palindromes is very, very important for understanding the odd length part. So let's look at the pseudocode that will make things a bit more clear as well. So the pseudocode is very straightforward. First, we need to build this array. So we haven't seen the code for that. The code for that would look something like this. We'll do a simple DFS, and we will. So this sort is not there. Sorry for that. So we'll just increment the frequency of path. So this frequency array could be this path is an array. So this frequency could be a map of vector comma int, right? So we will just increment the frequency of path plus plus, right? So frequency of 001 plus plus. Now for each child, what we want, when we are visiting a child, the frequency will change based on what character it is, right? So that's what we have done. We have calculated the new path which just have this particular character incremented, right? And because we don't care about the actual frequency and we care about the odd or even piece, we just take it modulus 2. And finally we send this new path along with the child node, right? So this entire thing would run in order n into c, where c is the length of the array, and in actual problem it is c is 26, but in this case c is just 3, right? Now once you have this array built out, what you need, we'll just simply need the even length palindromes. And for even length palindromes, as we have discussed, we can simply iterate over all the u's. So either you can iterate over all the u's and figure out what is the path of u, and then figure out what is the frequency of u. That is one way. And second way could be you can simply iterate over all the unique vectors in the frequency array, and for each vector you already know the count, right? And you will just increment your even length palindromes by count into count minus 1 by 2, right? So this is how you will calculate even length palindromes. Now comes odd length palindromes, which is slightly tricky, but I am very sure if you stay till the end you will be able to understand that as well. Now for odd length palindrome, or what does an odd length palindrome means? Basically it means that this odd sum would be 1. So we have, for even length palindromes has odd sum equals to 0. Now odd length palindromes would have odd sum equals to 1. In other words, if we sum path of u and path of v, we should get exactly one index where the sum is odd. Everything else should be even, right? So just to see this in action, instead of keeping this array now, I just kept this values here, like AC and CB and the BCC. Like basically instead of 010, I'm just writing B here, so that it is easy to understand. But in real world, like when you are implementing it, you will have that array as well with you, right? So this is exact same thing that we have discussed previously. This is exact same array, exact same tree with exact same computations. Now what we are saying is path of u plus path of v should be odd, or in other words, path of u plus path of v should contain exactly one odd element. And for that to happen, you need to select all possible v that can fit with this u. Exact same thing. So let's say this u has c. In other words, this u has 001, right? Now you want something here which if you sum up you will get exactly one index, not sure which one, exactly one index which has odd sum, rest all are even, right? Now there are three choices here, right? Either this can be odd, or this can be odd, or this can be odd, right? So let's try each of them one by one. So let's say this character is, or this frequency of this character is odd. In other words, we are saying that there is a u comma v pair for which frequency of A is odd, frequency of B is even, frequency of C is even, right? So for u, we have seen that frequency of C is odd. So what will come here? Odd, because you want this to be even, right? You want this one to be odd and everything else to be even. So for this one to be even, this one should be for this one to be even, this one should be 1, right? Or this one should be odd, because odd plus odd is only even. This is even. What should come here? Even. Why? Because you want final thing to be even. So even plus odd will not be even, so you are forced to put even number here. So this should be 0. And in the same fashion this should be 1. Why? Because you want odd here and this is even. So even plus odd is odd. So you want all the v's which have 101, and all such v will give you the odd, we will give you odd length palindromes when merged with this particular u, right? Now notice that this was just one case. Like we found out all the v's which can give me odd length palindromes where the the frequency of first character is odd, right? Now there can be, similar to this, there can be v's which will give me which can give me the odd length palindromes, but this time the frequency which is odd is character b, right? So if for this one, like for this one, we say that okay, every v which is 101 can give me this. Now for this one, what will happen? Again, let's just erase this. We want this to be even again. So because this should be even, this should be 1, right? We want this to be odd, and because this was even, we need to put 1 again here, because odd plus even is only odd. And this is even, we want even here, so we'll put even here. So basically every v which is 011 can also give me odd length palindrome when combined with u, right? So every v which is 101 will give me odd length palindrome when combined with u, where character a is odd. Every v which is 011 can give me odd length palindromes where character b is odd. Now in the very same fashion, you will get one more category in which character c is odd. So let's just try to figure that out as well. So again, same thing, we want this to be odd, and this is already odd, so we want a even number here. And in the same fashion, this both should be even, because we want them to be even. So in other words, every v which is 000 will also give me odd length palindromes when merged with this particular u. And this is all, like it is this is all because we are just considering ABC, but in real problem we have 26 characters, so we have to pick 26 outcomes as well, or in other words, we have to pick 26 number of v's that can give us this particular value. So the algorithm is straightforward now. For every u, you will figure out how many v's, or what all v's can be there that can give me an odd length palindromes. And how we'll figure out? You will just fix one of the frequency as odd and just see what should come here based on whether the original number was odd or even. And you will get some number of v's, and you will see how many, the count of v's which have 101, count of v's which has 011, and count of v's which is 000. So let's take one complete example to understand this. Let's say this is u. So you want all the v's for which you will get a odd length palindromes with this particular u. Now we figured out that these are the three kind of v's. So 101. So let's see how many are 101, or let's say, let's bring back this tree. So we have this u 001. Now we want v's. We figured out that there are these three v's which can give us the odd length palindrome. So 101 is this. We have 101, and we have 101, and that's it, right? So basically it says that this u and this v can give me a odd length palindrome, and surely you can see this path has just one a, which is indeed a odd length palindrome, right? In the similar fashion, it says that this u and this v can also give me odd length palindromes, and it is also visible. This path contains CAC, right? And if you see, CAC is a odd length palindrome as well. So notice that this 101 will give me odd length palindromes where the first character is odd. So, and we have seen that A was odd here and A was odd here. Rest B and C are even, right? In the very same fashion, you will get second set of characters. So this is the first set of characters. Let's label this with A, right? Or let's label this with VA. Basically, all the V for which I will get even length palindromes where odd length palindromes where A is odd. Now second is 011. So 011, you have this 011, you have this 011. So we have two 011s as well. So basically we'll get two more odd length palindromes with this U and V. You can see they both are odd length palindromes, and it is also sure that B would be of odd length, and you can see B is the frequency of B is odd only. A and C are even. And the last one 0 0 0, you will see there is just 1 0 0 0, which is this. So this will give you odd length palindrome where the frequency of C is odd, and we can see that as well. So basically with this, for each U, you will figure out how many V's are there, and you can see for each U, for this particular U, we got 5 V's which are valid. So we'll just increment our odd length palindromes with 5, right? And we'll do this for all the U's and get the answer. One small thing that you need to take care of here is uh, you will be considering every pair twice. Why? When this will be U, this will be VA for sure, right? Because of the property of the odd. Basically, we want this to be odd. So for this view, if you get this V, for this V as well, you will get this U. So if you are considering all the U's, you will get every pair twice. So every pair is counted twice. So in the final answer, you will just divide by 2 to get the final result, because every pair is counted twice, right? So that's the entire algorithm. How to implement it? One way to implement is go via this exercise that we have done. So basically, you can add a for loop and say that, okay, in the first for loop, I want A to be odd, and based on that, you will have some if else logic that if it is even, then this should be if this is even and we want odd here, then this should be even. Then it should be odd, and similarly if this is even and we want even here, then this should be even, and so on and so forth. So this is one way to implement this. Second simple way to implement is look at what's happening here. 0 0 0 1. You want at the end that one only A should be odd, rest all should be even. So you want something like this. So because you want this, and odd plus odd is even, even plus even is even, and odd plus odd is odd, and odd plus even is odd. This is following the XOR property. So XOR has exact same property. If you XOR opposite thing, you will get 1. If you XOR same thing, you will get 0. So because we want 1 here, we can simply XOR 0 0 1 with 1 0 0 and we'll get this particular thing, right? This is just a simple optimization. You don't need to apply this at all, or you don't need to make this observation at all, that it is simple XOR operation. You can use simple if else, and instead I would recommend you to try it if else and try to code this entire solution by yourself, so that you don't feel the need of this XOR. And after that, you can come back here and understand this XOR part and revisit or restructure your solution a bit. So what will happen is, for each number or for each U, what you will do, you have this particular U. Now you have 3 targets. Either you will get 1 0 0, or you will get 0 1 0, or you will get 0 0 1, right? Basically either A will be odd, or B will be odd, or C will be odd. So these are the 3 targets you want, and for each of these target you can simply XOR with each of these targets and get the final thing that should be, or final V that should be merged with this particular U to get this particular target, right? So the implementation is very straightforward. What we are doing, we are again iterating over all the paths and count, right? And for each of them, we are iterating over all the characters one by one, because we want ith character to be odd in this iteration. So because ith character is the only odd character, we want to XOR this U with a number which have only ith bit set. So this is the number which have only ith bit set, and we have just XORed with the current number, which is the path, right? And we get a V, and we just count the number of V's that are there, and each of these V can be paired with this U as well. So as we have discussed, at the end you will be getting every pair twice, so we just need to divide by 2. So we have odd length palindromes, we have even length palindromes, we can just sum them all up and get the total number of palindromes as well. The time complexity is very straightforward. Time complexity for this entire thing is just order n, because we are iterating over like this frequency array will have in worst case n distinct elements. So this loop will run in order n time, and inside this loop we are iterating over all the characters, which is c in our case. So this is the overall time complexity for finding out the odd length palindrome. And for even length palindrome, it was very straightforward. We just iterating over this map once. So this is just order n. So the entire complexity is order n plus order n into c, and we need one order n into c as well to build this array as well, right? So that is just one more part. So hope this entire solution makes sense. If you have any doubts in any of these, I would strongly encourage you to rewind and watch the particular section by yourself. And if you have reached till this point, I would strongly encourage you to pause and try to code and get it submitted in Leetcode as well, because that is the part where you will understand the fact that you haven't understood anything. So I would encourage you to code this entire thing by yourself. You can skip this XOR part completely and just code this particular piece with just if else as well, and that is also acceptable. So next we're looking at the code. The code is very straightforward. We have maintained this map of int comma int. Again, we like in this implementation, I have done one more thing. Instead of maintaining 0, 0, 1, I have maintained this in decimal format. So this is just a representation. This can be thought of as a binary representation of some decimal number. So instead of 0, 0, 1, I will be having 1. Instead of 1, 0, 0, I will be having 4, and so on and so forth. So because I don't need this entire array to just optimize it further, I have made it int comma int. Now what we are doing initially, we are just building the graph from the given inputs parent and s. After we have the graph, we will simply do DFS to build this 1 0 0 0 1 1, this entire array thing or frequency thing. And frequency for this frequency thing, the path is straightforward. We will just simply do frequency path plus plus, and then we'll just XOR with the current character which is in the path. So again, this can be skipped if you are implementing it by yourself, or if you are watching this video because you are not able to implement, you can skip this particular piece and instead write the logic something like this, where we have discussed about the DFS. I think this one. So you can simply have something like this, where you have this path. This sort is not there. You have this path which is an array, and inside this you will just simply be incrementing the character at that particular index. So this is just to avoid having an array, because that will incur extra time complexity. So I just convert everything to integer. Now after that, what we are doing inside is simple. We will figure out all the odd length and even length palindromes. So we just iterate over all the frequency array and get val and count. So it is similar to path and count. So we just name it val and count. Now if you remember, for even length palindrome, we just need to do count into count minus 1 by 2. So we just simply added this to the result. For odd length palindromes, we need to divide everything by 2. Sorry, we need to divide everything by 2 at the end, right? So because I am just adding one loop, I multiply this by 2 as well. So instead of counting to count minus 1 by 2, I just added counting to count minus 1. So that when I divide by 2, everything will be divided by 2 and we'll get the exact answer. Right? This is just a simple trick. Now to avoid iterating over this frequency array one more time. So now this will give us the contribution of the even length palindromes. For odd length palindromes, as I discussed, we'll iterate over all the positions, and this j here means that the jth character is odd, or the frequency of jth character is odd, all other characters are even. So for that we have simply figured out the required v, this other is v, and then we will simply add cnt into frequency of v into our result. So hope this entire solution makes sense. If you have any doubts in any of the problem or any other thought process, feel free to post them in the comment section below. I will be able to answer. If you like the video, give it a thumbs up and do subscribe if you haven't already. And I will see you in the next one. Thank you.